Welcome guys to our DSA challenge series. This is the phase 1 of our series and the questions we are tackling in this series are based on arrays. So let us see our today's question. The question says, given an integer array nums, you need to find one continuous subarray such that if you only sort this subarray in non-decreasing order, then the whole array will be sorted in non-decreasing order. Return the shortest such subarray and output its length. Let us understand this question with the help of example. In the example number 1, we are given an array nums which contains the element 2, 6, 4, 8, 10, 9, and 15. We can clearly see that this array is not sorted. The question says we need to return a shortest subarray such that if we sort only that particular subarray, then the entire array will be sorted. So in this particular nums, if we sort 6, 4, 8, 10, and 9, which will become after sorting 4, 6, 8, 9, and 10. So our entire array will become sorted. If we sort only this portion, then our entire array will become sorted. So the R subarray is going to be 6, 4, 8, 10, and 9. And the length of this subarray is 5 because it contains 5 elements. So I hope the question is clear to you all. Now let us see what is the approach of this question. The very first step is going to be, we are going to create a new vector sorted nums. And we are going to copy the elements of that sorted nums of the given vector nums into that particular vector sorted nums. Now both the vector nums and sorted nums will contain the same elements. The only difference is going to be nums will contain the elements and sorted nums will contain those elements in a sorted order. So the very first step is going to be, we are going to create a new vector sorted nums with the elements from the input nums vector and we are going to sort. After that, we are going to initialize two pointers, start and end, to track the subarray indices that needs to be sorted. We are going to initialize start with the 0, that is the first index, and end with the last index using nums.size -1. This is going to be our second step. After that, we are going to iterate forward through nums and sorted nums. We are going to simultaneously iterate through both of these vectors until and unless a mismatch is found. As soon as the mismatch is found, it means this is the first index of that subarray which needs to be sorted. In the similar pattern, we are going to iterate from the end of that array and going to compare the elements of both the vector nums and sorted nums. As soon as the mismatch is not found. As soon as the mismatch is found, it means that is going to be the last index of that particular subarray. Now we have the starting index of the subarray as well as the last index of the subarray. Now we are going to apply one condition if end is less than start. And if this condition is true, that means our vector nums which is provided to us in the question is already sorted. So we will directly return 0 in this case. Otherwise, we will return end minus start plus 1. End minus start plus 1 denotes the length of that subarray. I hope the approach is clear to you all. Now let us look at the code. The very first step that we are doing is in line number 4, we are creating a vector sorted nums in which we are copying the elements of our nums vector. In the line number 5, we are going to sort that particular vector. Now we have both the vectors nums as well as sorted nums. The only difference is that they contains the same elements. Num is not sorted and sorted nums is all a sorted vector. After that, in line number 6, we are initializing the two pointers start and end. Start with the starting index of the vector nums and end with the last index of the vector nums. How can we find the last index? Using nums.size -1. In the line number 7 to 10, we are applying a loop while start is less than nums.size and nums at the index of start double is equals to sorted nums at the index of start. If these both of the conditions are true, it means the mismatch is not yet found. The loop will keep on going and we are going to increment the value of start. As soon as the condition becomes false, it means the mismatch is found. Either the mismatch is found or we have iterated through the entire array. So in that case, our starting index will get some value. Then we are going to apply a condition while end is greater than equal to 0 and nums at the index of end double equals to sorted nums at the index of end. It means now we are iterating from the end of the array in the similar way for initializing the value of end. If the both of these conditions are true, then we will keep on decrementing the value of end. After that, we have used the ternary operator In ternary operator, we have applied a condition if end is less than equal to start, it means the array is already sorted and we will directly return 0. Otherwise, we are going to return end minus start plus 1. So this was all about the code. The time complexity for this particular code is going to be big O of n log n because we are sorting an array, and for sorting, this is the function used in the C++ SQL library. The time complexity is big O of n log n. We are also creating a vector sorted nums. So the space complexity will be big O of n. I hope the code is clear to you all. If yes, don't forget to share it with your friends and subscribe to our channel. Thank you.